Welcome to Season 12 of the Prosthetics and Orthotics Podcast. This is where we connect with experts in the field, patients who use these devices, physical therapists, and the vendors who help bring it all together. Our mission remains the same: to share stories, tips, and insights that help improve patient outcomes. Tune in and join the conversation. We're glad you're here and hope it's the highlight of your day.
Hello, everyone. My name is Joris Peels, and this is another episode of the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey, Joris, I'm doing well, man. Saw some interesting stuff. I know we talked about the Formlab stuff last time, and then there was a little bit of chatter. I think it might be our episode that actually went the fastest up, which is we kind of created this 3-step process of how to get involved with 3D printing.
Yeah.
And I thought it was really good. We actually should expand upon that. Maybe we should use AI to expand upon it for us. No. But I thought it was a...
I'm anti-AI. I'm an AI Luddite.
Okay.
This is a handmade podcast.
That is actually true.
With love by humans.
Yes, I do edit every single one of them and take out all the... There's ways to use AI to make it, but what I found is it does interrupt the flow. You know, I think we have flow. Other people may think that we don't have flow, but nonetheless, it is definitely made with love and caring for sure.
So who is our guest today?
So I'm really excited to have Fredrik Ericsson on with CADmed. And so the neat thing about what Fred is doing is really focusing on what are some of the ways that we can automate some of the processes, not only with foot orthoses, but now moving into AFOs and SMOs and potentially prostheses. We've been working together on some projects off and on for a while now, and I just really appreciate his take on it. He is not a clinician, and so it's always great to hear kind of like the software aspect of it, of why did it get done that way. And I might be going a little bit far. He may or may not appreciate some of my feedback, when I say, well, why did you do it that way? Or what about this? And so I'm really excited to have him on to kind of share his journey and then give us also a peek of potentially what is coming up, what is currently available, what is coming up. I think it's going to be a really good conversation.
Cool. So, Fredrik, tell us, how did you get involved with O&P?
Well, first, thanks for having me on. I got involved because my parents were involved in the O&P. So I started off pouring plaster, filling plaster casts, and then I got promoted to designing some of those positives. And from there, they saw that I could design foot orthoses from plaster positives. So my manager said, well, then you can design it on the computer. So I got to start doing CAD work at my previous job. And
how long have you been doing this? So this is CAD 3D printing or CAD orthoses kind of journey?
Well, more than 10 years now I've been working with digital foot orthoses, maybe 15 even. 10 years ago, I think I started CADmed. We started as just a production facility, and then we hired software developers to build the actual technology that we're using to produce the devices.
And is it now like true, like on the one hand, would you advise people now, if you want to look at this digitization thing, we say, you must learn CAD, this is the future? Or do you think there's going to be so many kind of semi-automated tools out there, you're just going to be press a button and then most of at least the data capture, the device building will be done like automatically?
Depends on what the type of device. And I think automation is for some things, it gives more control to the practitioner, because many times the prescription, at least for podiatry, they send in the cast and expect someone else to do the design and get it produced. With automation, you can take that a step back and give the practitioner the results in, let's say, 60 seconds, even less, 30 seconds. And then they can in turn change that, giving them more control over the final device. It depends on the complexity of the devices too, I think. I'm not a clinician, so my job is to make the practitioner and the O&P clinicians happy.
I think that's a pretty interesting way to look at it. And I haven't thought about it that way as far as automation can help you make better clinical decisions, especially if you're the one doing it real time and you're used to using a contract manufacturer that somebody else's hands are doing the work and it may not be exactly like what you're talking about. So I think that's a pretty interesting way of looking at it. In the podiatry realm, do you find that there are a lot of different styles of foot orthoses or say complexities or modifications, or can you kind of bundle them together to help people create these workflows that are specifically for them?
Well, I would say at least the clinics in the Northern Europe that I'm working to, you don't even have local differences in how they work. Within the same clinic, they have deviations in how they work. So it's a must to tailor the automations to the practitioner's wishes. I mean, they are the competent person. So if they decide that this is the way it should be automated or designed, we have to listen and give them that.
Can you share just a little bit? I mean, you mentioned that you've been been at this for a while. And I think the one thing that I found interesting or fascinating is, most people think digital and go ahead and move straight to 3D printing, but that's not necessarily the case. And there are some things that are worth 3D printing and some things that are just fast doing other ways. Can you share a little bit about your evolution of the digital space? Because I know you were doing some carving and things of that nature, and then picking and choosing what you're using additive manufacturing for.
Well, we've had when it comes to foot orthoses, moving to 3D printing hasn't been that easy because the clinics that we work with, they like to be able to correct and change the results, and it's much easier using EVA. But now that we're moving to materials like foaming TPU that are much more like EVA, and we're seeing it being there's a little bit more traction towards foaming TPU just because of the practitioner being used to the look and feel of a certain material. Does that make sense?
Yeah. And so can you tell a little bit about the speed process, though? Because I know that you do a lot of carving and still a lot of it. What does that look like? And why would people choose carving over 3D printing? And do you ever see a point where stuff moves more towards 3D printing, or is it really a balance between the two?
It takes us about 15 minutes to carve a pair of foot orthoses. And if we want the same finish using foaming TPU, 3D printed, it takes us about 3 hours. Having said that, now that the price has dropped so dramatically on these 3D printers, and they take a lot less space, if you look at Southern Europe, you've seen the shift already, I would say. But Northern Europe, it's a bit slower. But I think the shift is going to happen now. Maybe not for all, but for many, once they see the results that we're coming up with here, I would say. Is that too cocky?
No, I mean,
No.
I think that's interesting.
Yeah.
This idea of the carving being so fast, I mean, people really aren't fitting these things same day, right? So a little bit of time, say in the 3D printing, especially if you're getting pretty close, it's not really a big deal.
I don't care about technical time. If the investment in the machine is nothing and the space it takes to house the machine is minuscule, then 3 hours for a pair is nothing.
Would you also say that the technical time for getting to the end, or the automation side of things, where you have a workflow from the beginning to the end, right? From the clinician's hands straight to the printer, that's really what we're after, is not having all these little steps, but it's like you have the clinical and then you have the manufacturing, and whatever you can do under the hood for the manufacturing, that's going to be good for not only the patients, but also for the clinicians.
And you want to make that journey from scan to print as frictionless as possible for the practitioner. That's our goal.
So you mentioned a little bit about the foaming TPU and such. I mean, what are you seeing in that? Are you still treating these things with top covers? Are you doing 3/4 length? What are kind of some of the recipes that you're seeing coming out of because you're kind of tip of the spear with some of this stuff in the manufacturing?
We see almost zero post-processing on the foaming TPU, and we see almost zero waste. And the practitioners that we show these devices to, they say, well, this is very close to EVA. It looks better than the milled or the carved insoles. So I think for orthoses, it's just a matter of time. Or for us, it's just a matter of time before it switches to a larger amount produced by 3D printers. I know that other regions in the world, they're already moving, but maybe our region the Northern Europe region is a bit particular about their EVA, or I don't know. You guys know better why some markets move and others don't.
Where do you think the story lies to push people, or that will ultimately push them in a direction to this kind of zero waste, beautiful foot orthoses that is 3D printed, even though it may take a little longer?
I think the finished device has to look as the practitioners, what they're used to.
I think, to me, I think the interesting bit is that with what we can do with 3D printing ultimately is we can make like a gradient insole, or we could just change it at every single point, right? We could change the infill and put in pockets of air, and we could really do things that you can't do with a subtractive process. So that to me is like, that's the part where you'll be better, objectively better, and we're creeping towards that, I think. But I think it's important for the audience, I think, maybe to look a little bit at foaming TPU, what it is, because TPU is basically a relatively broad category of elastomeric materials, different shore hardnesses and stuff. And the cool thing about foaming TPU is a foaming agent in it, and using the nozzle temperature, you can change the nozzle temperature of your printer, and you can change the degree of expansion of the foam. So you can change that, how that works, how that expresses itself in the model. So Fredrik, what does that mean for you using foaming TPU? What is the big difference? Apart from just the looks, we've gone over that. But what else is the main difference there?
Well, we can get it a bit softer than regular TPU, and it's not as plasticky. We have not spent too much time changing hardness using nozzle temperature. We try to do changing infill density or lattice structures to modify density. Mostly it's you can get away from this plastic feeling.
It feels like much more luxurious and kind of, I don't know what it is, like foamy. I don't know. It feels more like a kind of gel liner-ish, I guess. I don't know how to explain it really. But there is real, and there's an added comfort benefit, right? Or do you have good feedback from people? And then I've heard good things, but I don't know if you've heard so many good things that they really think these things are very comfortable, right?
Yeah. The problem we've had with uncovered EVA that are directly milled from the EVA block is that it's that the surface is a bit rough, and this is a non-issue with foaming TPU if you print it in the correct way. If you print it what do you call that? Well, if you print it on a regular XYZ machine from bottom layer to top layer, you might get some need to post-process to get that layer height to disappear. But if you do it on, for example, a belt printer, you get none of that roughness.
Yeah, I like this. So you guys are using Delta machines right now, or?
No, belt.
Oh, belt. Belt driven. Oh, okay. That's interesting. Okay. So, so a little bit also for the audience, we have Cartesian called or gantry type printers, a bit box, the printer you're probably familiar with. You've seen at your kid's house or something like that, or your kid's friend's house, something like that. Those are great for a lot of things. But of course, you want to do production. There comes a lot of, you have to every time open the little door and get the print out. And of course, there's some really, really weird things about printing TPU that mean it's one of the trickier materials to print if you would be printing at home. And then there's an alternative, and that's a belt-driven printer where you're basically putting a conveyor belt below a gantry, and then you're printing in profile, I think is the best way to describe it, which is great because you can print shoe after shoe after shoe, but also it really lends itself really well to printing TPU specifically, right?
I would say so, yeah. We bought our first belt printer because we really saw this continuous printing as an advantage. But I think we're on our fifth one, and
we don't have time to get into
started
it,
with the Creality
but we do need to
C30,
devote
I think it's called. right when it
episode of the podcast.
got released.
So
We
some
bought a
codes
couple
came
that
out
were pretty
for
expensive
Medicare
as well.
4-point
But now
designs.
finally we think we can get it tuned
I'm not
in
trying
well.
to
The
derail
low
this whole
cost machine
conversation,
tuned
but
in well for TPU.
it ended up not
yeah,
being
because there's a
super
bunch
favorable.
of belt printers.
So
Would you mind,
it's
like,
just,
you don't have to, but would you mind telling me, like, what setup you're the most happy with right now and why? Because there is a bunch of belt printers out there from, like, $1,000 or something to tens of thousands actually, and there's a big range out there in pricing and capabilities and stuff. So.
And what do you want to know?
Well, which one are you happy with, or what kind of setup are you happy with, or what should we look out for if we want to get
dive
into
into
this
that.
belt printing thing?
Basically, I would say it's possible to now. Maybe that's on the slicer side that we've gotten better. But I think you could tune in any of the
there's always been
less
tooling from molds has always been like a big deal, and I mentioned the extra thing. But now we're seeing a ton more tooling examples.
I think that's interesting too.
It's polymer tooling, like tooling made on like a forearm,
but
also tooling made in metal.
Really, they've become hardware.
Injection molding.
How do you actually
relatively low run injection molding, packaging,
it's really in
medical packaging, all this kind of stuff,
and the tool pathing,
that was
the
like,
design side. And that's really where a lot
really
of the
very, very high quality, high precision type of stuff. Apart from the orthoses, are you using 3D printing for anything else in your business, or not really? And then also, now with all the bit of chaos and stuff, we're looking much more towards making these molds better. I saw a styrofoam mold tool, which I'd never seen before.
Hybrid
I'm not entirely sure that'll work.
Devices where we might mill a rock or so, and then
we saw mold tools for latex. We saw mold tools for two component stuff.
Some parts, and then we combine them together.
Mold tools for and are you like investing more in 3D printing? Where do you want to invest more in 3D printing? Like, that's something for machines, training out there. I think
so what we're investing a lot of time with our developers to build functionality for 3D printing,
or tooling or insert, something like that.
And
that's
the
actually maybe a lot more affordable than you think.
These are things like gradual infill density or gradual lattice structures to control density
much more
in the CAD software rather than doing it just by modifiers in a slicer. We want to go in and actually build the functions for the designer to control that. So we spend a lot of effort and time on the development side, but we also try to invest more in machines on the printing side. We have not. Sorry.
Go on.
We have not gone full on the HP powder bed stuff because for us, it's too much of a risk investing. We're a small company, so it would be a big bet for us to buy one of those machines.
No, but it's a very sensible thing. But especially if you're afraid, it's a good sign. It means you're cognizant of what the limits of the business are, and I think it's very good. Better than just drunkenly going and buying all sorts of stuff you don't need. So I think that's just very sensible.
After form next, is that what you're saying? It happens sometimes.
Exactly. No, I mean, I think it's sensible approach. And then if you're talking about like, giving control in CAD to like lattice structures and stuff, why is that important? I mean, you're talking a little bit about that. What can you really do as a designer or at the design stage with lattices to really change an object?
Well, if, for example, if you're going to print a photo orthosis in powder bed fusion or some liquid resin printers, what we can do within our software is to fill the inner space with the unit cell and then gradually using a brush to change the strut diameter of that unit cell in different places. So effectively using one material, but getting multiple properties.
Yeah, I think that's really exciting because that could already give you that gradient. You could create a cushion zone somewhere. You could create a different thing under my toe and then a softer area around, right? Are you seeing a lot of experimentation with that, or is it very early days for people to be working with that?
Well, we did see, but then FDM took over photoorthosis for 3D printing. I think it is too expensive to use powder bed fusion, that's what I call, to print photoorthosis when you can do it with TPU on a printer like the Bamboo Lab or super inexpensively. Is that the word?
Yeah, well, low-cost printers are inexpensive. Okay. I think that's an interesting perspective. I think, and have you looked at also like if you printed like hundreds at a time and stuff like that, it just generally just the material costs, the process costs just make it really expensive for this one part, right?
I mean, we could never get up to the volume. It was always a catch-22 for us because we go to these service bureaus and they say, well, we can get the price down for you if you order 60 parts or whatever, but we could never get the 60 parts from our customers.
I think that's an interesting insight there too. And would you, I mean, you don't have to answer this if you don't want to. Would you say that sometimes, and I'll just speak for orthotists and prosthetists, sometimes we get a little bit too into what works or what doesn't work, and we may overcomplicate the process, specifically around foot orthoses. I'm not saying alignment's not important, but I'm like, okay, like multiple durometer over 10 centimeters, is that really going to make, or not 10 centimeters, 10 millimeters, is that really going to make a big difference for the normal type of thing? We're not talking about diabetic care, wound care, that sort of thing. Would you say that in some ways having additive manufacturing and the tools available now that weren't necessarily available in the traditional fab potentially could cause like an analysis paralysis sort of thing where you actually overthink the product that you're making?
Just being able to control the inside of an orthotic insole, like very specifically, is so cool. But as you say, do you need that? And could you compare if you have to pay $60 for a pair, whereas doing almost the same on an FDM printer where the material cost is less than $10? I would say the FDM is good enough, and there are ways to get that variable density gradual using FDM as well. I'm not sure. It's so easy to just get amazed by what you can do and forget that someone wants to pay for this rather inexpensively.
Yeah, I think even specifically with orthoses and foot stuff, I think that the material extrusion has the advantage because we can encapsulate within the TPU, we can encapsulate chambers of air, right?
Mm-hmm.
We can't do this with SLA or advanced polymerization. We can't do this with the powder bed fusion processes. So encapsulating air and creating a bit of air around your toe, or where your toe used to be or whatever, there's something that we can do that custom for you in a particular air chamber for you, depending on your weight or whatever. Right? And that's something I think I hope more people pay attention to that because it's something that is huge, I think. And then, yeah, just like you described, we can just change the lattices. We can change the lattices at every layer. We could change the lattices and the honeycomb structure and the wall thickness and the shapes. And we could change different infill structures, which people don't really do. And then, of course, you can also fill these chambers more or less with a different material or with the same material. And then you can get like something that is like, I think even much more gradient than you can get with another process. So I do think in the long run, even if the cost advantage, and I love that, but just process wise, I believe more in material extrusion than I do in the other processes for all the foot related stuff.
Yeah, and I think I agree with you on that.
And how is it like for you to look forward? I mean, are you looking at like, we're going to expand hundreds of 3D printers, or we're going to look at post processing, or where do you think your value is? Because we were talking before, in the software, in the settings. You can have more machines than anyone else. You can have better material. Where do you think if you're gonna win, or if you're gonna outperform other people? Where do you think the real area is to outperform?
It is possible now if the central fabrication won't be as applicable. If the machines doesn't cost anything and the space they take up is nearly none, what's the reason for having those machines in one place producing centrally and then shipping? You could have them closer to the actual patient. So perhaps the frictionless system is the way to expand the business, if that makes sense.
Yeah, totally makes sense. I think ultimately, I think that we could be going there, but there's still a bunch of things to be solved. I think, like, how are you doing on reliability, repeatability, for example? If you print these things out on Monday and Tuesday, are you getting the same results? Are you getting that kind of a consistency?
Well, that's something we're about to hard test. So I couldn't give you, again, not a lot of our production is 3D printed at the moment, but yes, there needs to be some hard tests on the repeatability.
And apart from are there other technologies you're also looking at where you're like, oh, laser cutting could be cool, or generally other digital technology? If you believe in that whole idea, like, hey, the CFAB is going to disappear and people are going to be...
No, I did. I posed the question. I don't think it will disappear, but it might sometimes be for some devices useful to have it closer to the patient. I wouldn't bet my life on, the fact that CFABs.
That's fine.
But I could see I could see the winners going there and providing the systems that allows for that rather than the ones or having the flexibility to do both might be a, a way.
What do you think like if you're working with podiatrists or O&P, what are they looking for? Are they looking to save costs and bring it in-house via software and maybe some of the stuff that you're making? Or are they looking to say, we don't really want to make any capital expenditures. We want to use a contract manufacturer that just makes it easy for us?
Well, in the market where we provide the actual devices, it seems to be moving towards cost, because it's the reimbursement system is not allowing for a lot of margins on these. Well, here's where 3D printing could be the way to cut costs, because you don't have to pay for shipping if you have it in house. You can get it's easier to get a finished product right down to put it in the shoe with 3D printing, I would say, which cuts time in the grinding room for the practitioner. So in the market that I'm in, it's all a lot about cost and efficiency and workflows for the practitioners.
Are people looking to bring it in-house or are they looking for contract manufacturers?
I think both. I mean, where it they could give them an advantage is in delivery time, I think they want to go in-house, and if it's possible for them to save a buck, in-house will also be preferable. But that's not what we see in my market now. Now there are a couple of big producers centrally, but perhaps with 3D printing we can move. I mean, you have to also realize that just the shipping alone is a big disadvantage to having a central fab in terms of the environment.
And it just adds time, right? So do you see a world in where a number of people, if the cost is negligible, say to do FDM at their office, they do that internally just to avoid some of that and have a quicker turnaround time? Or does that even really matter?
I think that's where we're moving towards.
Okay. So it sounds like the stuff that you're really working on is how do you get people to that point of that process where ultimately they save the most money by taking control of their own production?
What do you guys think? But yeah, I would see that's probably where it's moving towards.
Yeah.
Curious, Joris, from your perspective, because I know you've been involved with some of these foot orthoses things.
Yeah, it depends. I mean, I think still, I don't know. We can talk a little really specific, but really broad trends focusing on the orthosis thing. We're seeing people come up with solutions like Materialize tried this, a bunch of other companies tried this, and they usually relied on powder bed fusion, which Fredrik already knows. Yeah, he figured that out already before all these giant companies. So that's just a non-starter. But I think there's a huge opportunity for someone to come up with an integrated kind of solution, material printer, scanner, with the whole thing, right? I know Poto Printer, other people are trying to do this. And if somebody could do this around like a desktop type of system, I think that could be a really very valuable kind of thing. If they just like completely automated the process, you could put it in any kind of office and it would just be a really cheap way for people to make money, like kind of like a vending machine, like a Coke machine for orthoses. That's a big opportunity. What Brent and I have discussed a couple times as well is there's a bigger opportunity out there as well, right? There's orthoses think about talking to a company like UPS or the US Army or the NYPD, right? And say, hey, you've got a bunch of people, hundreds of thousands of people walking around on their feet. We could scan all your feet and give them better insoles and things. So that's a big, and then there's a bigger opportunity maybe, which we don't really think is going to happen, but to give a bunch of people who are running or who are getting back pain or something, an orthosis in like a retail type environment or a better fitting sole along with their next pair of Nikes. So there's like a kind of like, I think there's a chance that at one point we're going to get somebody who takes his vending concept to the next level and just does it. And that's going to open the floodgates. Up until then, I think there's a really huge opportunity for services to take this on really quickly. But I do agree. And if you would have asked me, I think last year, I would have said, yeah, the printing FDM or material extrusion, a TPU is too annoying. The repeatability is low. We're getting too many errors. It's too finicky. It's not going to work for most people because it isn't fire and forget. And I think it's like, that's why I'm kind of enthused by Fredrik wanting to test this out and kind of going in that place where Oh, it is kind of reliable, and it is kind of, we have dialed it in to the point where it kind of works most of the time, or it works a lot of the time. And that to me is the real point. If we're getting to a point where you can give people a process where they can do this a lot of the time, it'll just pop out by itself without having to do anything. Even if it fails and after then, print it again, once every 5 or 6 times, then it's still going to be okay. And that would just depend on that package of the material and the printer being better and better. And we're seeing bigger bamboo type printers, these more efficient, bigger systems. Of all the materials they do well, they do TPU the worst. This is a bit of a problem. But I think with foaming, exactly like Fredrik says, and some other developments, other kind of filled and kind of chemically assisted materials, we're going to really see a real difference. I was blown away by the ColorFab Zellerfeld shoes, for example, and just wearing them and playing around with them. They're incredible. And they are using a lot of that different hardnesses and different types of texturing and stuff. And that is a really next step. So I think ultimately, I think the most logical thing is for everyone to have like a semi-autonomous system that just can do anything from, that just does the whole process. Like we talked about before, that Chinese company that was offering kind of, the footbed scanner, the walking thing, everything, And that to me is kind of in an office is the ultimate thing we're headed towards, I think. But then also having a second tray, just put the stuff you've used in it so you know exactly where you are.
I think what they're doing is cool.
That kind of stuff is really simple.
I'm a 3D printing nerd, but
if you make the tray and it kind of doesn't work,
can buy that stuff.
That's okay. I have no idea. I really don't know.
You know what I'm saying? Like it's like, okay, so it's like 200,
but I think it's really interesting.
For advanced procs,
when we did a similar question like this a couple years ago, and we both were
what they've done. I think it's amazing. And a 4 to 6 week lead time on your shoes that you order. I just like for the American market, I just don't think it's going to work because other than people that are into 3D printing, there's nobody waiting 4 to 6 weeks for a pair of shoes that cost $200.
No, maybe, but that's just an interim thing,
Sure.
It's interim stage.
Yeah.
I think
so.
At one point,
I love the innovation. That's all I'm saying is, it's a hard, it's a hard sell. Now, what I love about what Fred's doing is he's pushing the envelope of the FDM side of things. I love powder bed fusion. I love powder bed fusion. I run 5 different powder bed fusion machines, but to me, powder bed fusion does not make sense for foot orthoses. It's too long, it's too expensive, and you can get a lot of the same properties out of FDM, whether it's the TPU side of things or even some of the shell stuff. I mean, some of the modified polypropylenes and even some of the nylons and such, if you want to go to more functional foot orthoses. So I think FDM's absolutely the way to go. And I love the idea of being able to do this on a low-cost printer. I mean, we already work with a few clinicians where we're just doing the design side of things and we're sending stuff to their printers and both prosthetics, partial hand prostheses, arms, some test sockets. And I think that's the way it's going to go. It saves time, saves money on the shipping side of things. And then obviously it saves cost because they're taking the burden of the manufacturing and bringing it in. So I think there's a lot to what Fred's building, and I do like that.
That's cool. And Fred, how about that? How about this whole idea of outsourcing design? Because we keep talking about that as well. How about people like, maybe I print at my house or at my office, but I outsource the design to India or a different company. Do you see that happening as well, or do you think people want to have that control?
No, I know that we are running that project today. So we're controlling a couple of printers that we set up in a different country. All they do is scan the foot, and we do everything else from design to slice to even starting the machine remotely. So yes.
That to me is like super exciting. That's what I was talking about with that Coke machine, right? Where it's just like literally like you get a little message on your phone, like a WhatsApp or whatever, like, hey, change the filament.
Yes, that's what happens. Actually,
really?
I just did. I just said to one guy, you have to switch the filaments. And he's like, well, I'll do it tomorrow. So, but you need systems for this to scale. Yeah, because I cannot sit on WhatsApp with that.
And what are the findings of the people you're working with? Are they really happy with this? Or are they a little bit weirded out that there's just they don't have any say over it? Or they're just like, oh, it's easy money? Or what are they happy about?
They're happy about the fact that they don't have to wait. I mean, these are small physio clinics that we're working with, and they were used to waiting for about 2 weeks to get the device, and now they can get it within a couple of hours.
And what are you offering to them, or what are you selling to them? Are you telling them that you pay? Do they pay for the printer, or do they pay per design work, or do they just pay for the orthoses, or what?
They pay for the orthoses in that case.
Okay.
So we charge them for the ecosystem around it, so that their job is to remove or fill on new filament and remove the build plate and insert an empty build plate. In that, this is sort of like a pilot project whereby we charge per pair.
That's really that. I think to me is really exciting, because I think that is kind of the future where, if that's just if that just becomes a profit engine that just sits in a corner of your clinic, and you don't have to, maybe you change the filament once a week or whatever, or you have to, run a calibration thing or oil some rods, every couple of weeks, and then the only thing it does is spit out money for you. I think that's very compelling, And then maybe the beautiful thing is, maybe if you had the financial wherewithal, you wouldn't even have to charge them up front for the printer. You would just say, "Oh, put it there, and I get to make all your orthoses and charge you per orthoses," right?
And that's what we're doing in this case. So they don't pay for the machine in that pilot project that we're running. So then it becomes, for the practitioner, fairly frictionless. But to scale that, you need systems, and someone has to build those systems.
Yeah, totally. I think that's that could be, but that could be a future. Just at least for orthoses, I think that to me looks like the future. Like, for example, if the future of all the other stuff you guys are talking about, prosthetics and stuff, that to me is like 100 times more complicated. I'm not saying that orthosis isn't hard to do or isn't important. Just there's like so many more variables. So I don't know. Okay, so Fredrik, and what's the main thing that you've learned with your 3D printing journey so far?
Well, it's just these things that are cool that you want to do, that you then realize there's no use just because it's cool. It's not going to help anyone, or there's not going to be a market just because it's cool. So I've learned to stay away from shoes, because I don't think anyone is going to buy a custom shoe with when there's nice fabric that hugs your upper. It's going to be a hard sell too.
To get on the other side of that, I think there's one thing that I would like to remind you of is Patron tequila.
Okay.
And you might not have the first time somebody explained to me that there was a bowl of tequila out there that was $80 or something, I was like, what? And after all these people started buying like $60, $70 tequila or something, I was like, I'm pretty sure we could sell people anything at this point,
Yeah, but maybe I'm wrong.
Yeah, no. I don't know. I just don't know what like a 16-year-old person now cares about and what they find important, And I don't know how far we can get on the material side of things. So yeah, I don't know. But to us, it's just like it's a really expensive crock. But there's a lot of people that wear crocks, right? So I don't think we really know what we're going to do there. But yeah, so Fredrik, thank you so much for being here today with us. I think it's really great what you're doing, and really leading the charge on material extrusion and orthoses and a lot of the CAD stuff around it as well. And I love the outsourcing project as well. That sounds like it could be the future of the whole industry. So thanks so much for being on the show today.
Thanks for having me.
And Brent, thanks to you for being here as well today.
This was great, and it was great to hear kind of the progression of where we're going. And I think the future is bright for the foot orthoses, even though it's becoming more of a commodity. I just really appreciate Fred's take on, okay, so if that's the case, how do we help that process along and be a part of it and make it a frictionless process? So I thought that was really cool.
All right. And thank you for listening to another episode of the Prosthetics and Orthotics podcast. Have a great day.